Any random variable can be transformed into the standard normal random variable, or the z-score, to derive the relevant probabilities. A normal distributed random variable x with mean mu and the standard deviation tau can be transformed or standardized into the standard normal variable z with mean 0 and the standard deviation 1. We transform x into z with the following formula. Now let's try to solve a case finding the probability of a random variable that follows a normal probability distribution by transforming the random variable into the standard normal variable z. Here we have a case where scores on a management aptitude exam are normally distributed with a mean of 72 and a standard deviation of 8. What is the probability that the randomly selected manager will score above 60? To find the probability, we first transform the random variable x equal to 60 into the standard normal variable, or the z-score. From the case, we have the x is 60 and the mean value is 72 and the standard deviation is 8. We insert the numbers into the formula like this and get a result where z is equal to minus 1.5. So that is how you transform your random variable x into the z standard normal variable. But we haven't solved the case because the question is, what is the probability a randomly selected manager scores above 60? Graphically, we are looking at this green shaded area, because we want to find the probability that a randomly selected manager scores above 60. How do we find the answer? To find the probability, we use the z-table. There are different formats of table, but I will use the table that provides cumulative probability, where the area that is resulted from the table shows the area of probability where z is smaller than or equal to the amount of z that we are looking for. So here, this is how a z-table looks. The first column shows value of z up to the 10th decimal point, while the first row of the table shows the 100th value from the z. The number inside the table are the probability value for each z value. Now, let's learn how to find the probability from the z-table. From our case, we got z equal to minus 1.5. Here, I duplicate the z-table. We match minus 1.5 on the z column with 0.00 on the z row to find a corresponding probability of 0.0668. But since the table that provides cumulative probability where p z smaller than z, this result tells us that the p z is small. The probability is the area of z smaller than minus 1.5, or the yellow shaded area. So 0.0668 here is the yellow shaded area. To get the green shaded portion, because we want to find the probability of x is greater than 60, since we know that the total area below the curve is equal to 1, then we just need to subtract as follows. Thus, the probability that a randomly selected manager scores above 60 is 0.933T2, or 93.32% is this green shaded area. Now let us try to solve the second case. What is the probability that a randomly selected manager will score between 68 and 84? Just like the first case, we convert the random variable x, 68 and 84 into z, and we get z1 equals to minus 0.5 and z2 equals to 1.5. From the table, we get that the probability of z when z is smaller than 0.5 is 0.3085. This probability is equal to area A, or the yellow shaded area. And the probability when z is smaller than 1.5 is 0.9332, or area A plus area B. But since we are looking for the probability between 68 and 84, thus we are actually looking for area B only, the green shaded area. To find it, we just need to subtract the probability of area A and area A and B. And it's just 0.9332 minus 0.3085 equals to 0.6247. So the area B here, the probability is 0.6247. In other words, the probability that a randomly selected manager will score between 68 and 84 is just 62.47%.